For years, we believed the laws of physics were unbreakable. But a new experiment conducted by Google's quantum research team has recorded something that simply shouldn't exist. The chip's calculations defy logic, with results appearing before computations even begin, and data shifting in ways no one can explain. Have we just uncovered a hidden force, or is this a glitch in reality itself? If this anomaly is real, it could mean one of two things. Either we're witnessing a new fundamental force in the universe, or the fabric of reality isn't as stable as we thought. What if the laws of physics aren't as stable as we think? What exactly did Google's quantum chip detect? Google's quantum research team set out to conduct a routine experiment, one that should have followed the well-established rules of quantum mechanics. Using their state-of-the-art quantum processor, they ran high-precision simulations designed to model complex quantum interactions. The goal was simple: observe and refine how quantum systems behave under controlled conditions. But something bizarre happened. Instead of following predictable quantum mechanical behavior, the chip began producing results before the calculations had even started. Data log showed outputs appearing milliseconds before the computations were initiated, something that should be fundamentally impossible. It was as if the chip had already processed information before being given any instructions. Even stranger, the chip's quantum states refused to collapse the way they were expected to. In quantum mechanics, superposition allows a quantum bit, or qubit, to exist in multiple states at once until it is measured. But in this experiment, certain qubits remained in an indeterminate state far longer than they should have, resisting the natural process of decoherence that typically forces them into a definitive outcome. Then came the most unsettling discovery. When scientists repeated the same calculations under identical conditions, the results weren't always the same. Despite running the same simulations with the same inputs, they observed fluctuations in the final outputs, as if some unknown variable was interfering with the system. This wasn't a simple computational error. There was a pattern to the inconsistencies. Had Google's quantum chip tapped into something beyond our current understanding of physics? Was it interacting with an unknown force, or had the experiment revealed an underlying flaw in our knowledge of quantum mechanics? If these anomalies are real, they could change everything we know about computation and reality itself. Are we witnessing a new quantum effect? The anomalies recorded in Google's quantum chip have left scientists scrambling for explanations. If these results are not just a computational glitch, then they may be pointing to something far more profound, a completely new quantum effect that challenges everything we thought we knew about the behavior of matter and energy at the smallest scales. One possibility is that the chip is interacting with an unknown quantum force. In traditional physics, all known forces, gravity, electromagnetism, and the strong and weak nuclear forces, have been well defined within the standard model. But what if there is another force operating at the quantum level? One that only becomes apparent under extreme conditions, like those created in Google's experiment. If true, this would be one of the most groundbreaking discoveries in modern physics, forcing a re-evaluation of the fundamental forces that shape our universe. Another theory suggests that the anomalies are not the result of an external force, but rather a previously undiscovered property of quantum mechanics itself. For decades, physicists have worked within the framework of quantum mechanics, believing that superposition, entanglement, and wave function collapse define how particles behave. But these new results could hint at a deeper layer of quantum behavior, one where time, causality, and even probability itself may not function as we previously thought. Some researchers suspect that this could be evidence of quantum fluctuations beyond our current models. Quantum fluctuations are temporary changes in energy that occur spontaneously in empty space, but they typically exist only for infinitesimal moments before vanishing. Yet, in this experiment, these fluctuations appear to be leaving a measurable impact, suggesting they may not be as transient as once believed. If these findings hold up, it raises an even bigger question. Has quantum computing just unlocked a hidden layer of reality? Could it be that quantum processors, operating at unprecedented levels of precision, are revealing a deeper structure of the universe, one that traditional physics has never been able to observe? This experiment is changing everything we know about quantum mechanics. What do you think? Are we witnessing a scientific breakthrough? Or is this a warning that we are meddling with forces beyond our control? Why scientists are alarmed? At first, some researchers suspected that the anomalies recorded in Google's quantum chip were nothing more than system errors, glitches in the hardware or software, computational noise, or random quantum fluctuations. But the more they studied the data, the more disturbing the patterns became. These weren't just isolated miscalculations or statistical outliers. The anomalies followed a strange but repeatable pattern, something that defied simple explanations. One of the most baffling observations was how quantum states behaved as if they were linked to something unseen. In standard quantum mechanics, entanglement allows two or more particles to share a connected state, even if they are separated by vast distances. But in this case, researchers found evidence that qubits, normally confined to interactions within the chip, were exhibiting behaviors that suggested they were being influenced by an external, unknown source. It was as if something invisible was guiding their states, forcing them to behave in ways that couldn't be explained by existing quantum theories. Another unexplained phenomenon was the shifting of data in unpredictable ways. Despite running the same quantum computations repeatedly, the output showed variations that had no apparent cause. The inconsistencies weren't random. They appeared to follow a pattern, though one that scientists have yet to decode. It was as if some external force was subtly interfering with the quantum processes, nudging the results in ways that shouldn't be possible. Then came the most alarming discovery. Unusual energy surges within the quantum chip, with no clear source. Normally, quantum processors operate within extreme conditions, near absolute zero temperatures, shielded from environmental interference. Yet, energy fluctuations appeared in the system that couldn't be traced to any known input. These surges were brief but significant, as if the chip was momentarily interacting with an unknown energy field. Some physicists now believe that what Google's quantum chip has uncovered may extend beyond our known universe. If these anomalies are real, they could be the first signs of an undiscovered layer of physics, one that operates outside our current understanding of space, time, and energy. Could it be that quantum computing has inadvertently tapped into a force that exists beyond our observable reality? And if so, have we just opened a door to something we don't yet understand? Has Google's quantum chip opened a new door in physics? The anomalies observed in Google's quantum chip have left scientists with more questions than answers. If these findings are real and repeatable, they suggest something far more significant than a simple computational error. Instead, they could be evidence that we have stumbled upon a deeper layer of physics, one that has remained hidden until now. One possibility is that the chip is interacting with quantum fields previously unknown to science. In modern physics, the fundamental forces of the universe, such as electromagnetism and gravity, are thought to emerge from underlying quantum fields. But what if there are additional undiscovered fields at play? If the chip is tapping into one of these, it could mean that quantum computing has crossed a threshold into unexplored territory, revealing aspects of reality we were never meant to see. This discovery could also represent a radical shift in our understanding of computation itself. Until now, computers have been seen as tools for processing information based on fixed algorithms and known physical laws. But if quantum processors are beginning to interact with something beyond classical computation, it raises a disturbing possibility that reality, at its most fundamental level, is not as deterministic as we once believed. Some physicists are taking this idea even further. speculating that these anomalies could be precursors to the discovery of new dimensions. Theoretical physics has long suggested that additional dimensions beyond the three we experience may exist, hidden within the quantum fabric of the universe. If the chip is somehow interacting with these dimensions, either leaking data into them or pulling information from them, it could mean we are on the verge of a breakthrough unlike anything in human history. But the implications go even further. Some researchers have proposed an even more mind-bending theory. Could this chip be leaking information from another part of the universe? If quantum entanglement truly has no spatial limitations, and if information can be exchanged across vast cosmic distances instantaneously, is it possible that the anomalies detected in the chip are not originating from our reality at all? Or is it something even more unsettling? Has quantum computing tapped into a force far beyond our control? If so, what happens next could be unlike anything we've ever encountered. The potential dangers of pushing forward scientists are now facing a dilemma. Should they continue testing Google's quantum chip, or should they stop before they go too far? What started as a controlled experiment has turned into something far more unpredictable. Some researchers argue that these anomalies could be the key to unlocking an entirely new branch of physics, while others fear that continuing could lead to consequences we don't yet understand. The best-case scenario. If these quantum anomalies can be studied and replicated, we may be on the brink of a groundbreaking discovery, one that could lead to massive technological advancements. Quantum computers are already poised to revolutionize fields like cryptography, artificial intelligence, and medical research. But if the chip has truly revealed an interaction with undiscovered quantum forces, it could mean the next evolution of technology, a new form of computation that surpasses anything previously imagined. The ability to manipulate quantum fields directly could lead to unprecedented control over energy and matter, a deeper understanding of the fabric of the universe, possibly unlocking interdimensional communication or breakthroughs in space travel. The worst-case scenario. Some physicists are warning that we may have already triggered a chain reaction we can't stop. Unlike classical computers, quantum computers operate at the fundamental level of reality, manipulating particles in ways that interact with the universe at its deepest structures. If this experiment has indeed disrupted something we don't fully understand, the risk could be far greater than expected. Among the most unsettling possibilities, the anomalies could destabilize quantum systems beyond the chip itself, affecting other forms of computation and possibly even biological systems. If the chip is leaking information into an unknown dimension or receiving interference from another realm, we have no way of predicting the consequences. Some scientists worry that an unstable quantum effect could expand beyond the lab, disrupting physics at a larger scale. Could we be unknowingly tampering with forces that hold reality together? This leaves us with an urgent question. Have we crossed a line that cannot be undone? Have we seen this before? Google's quantum chip may have uncovered something new, but this wouldn't be the first time scientists have observed bizarre and seemingly impossible behavior in the quantum world. Throughout history, experiments in quantum mechanics have revealed effects that challenge our understanding of reality itself. Could this new anomaly be an extension of one of these unexplained quantum phenomena? 1. The delayed choice quantum eraser. Can the future affect the past? One of the strangest quantum experiments ever conducted suggests that decisions made in the present can retroactively change events that have already happened. The delayed choice quantum eraser experiment, first proposed by physicist John Archibald Wheeler, involves firing a single particle, such as a photon, toward a screen. Before the photon reaches its final destination, it must pass through a setup that gives it two possible paths. It can behave as either a particle or a wave. Normally, once a particle is detected, its behavior is fixed. But in this experiment, scientists introduced a delayed decision, waiting until after the particle had seemingly passed through the apparatus before deciding whether to observe it. The shocking result: even though the photon had already traveled through the experimental setup, its past behavior changed based on the later decision. This implies that the future can affect the past, breaking the very idea of cause and effect. Could Google's quantum chip be experiencing something similar? Are the anomalies appearing before the computations because some quantum process is rewriting history at a microscopic level? 2. Quantum tunneling. Particles vanishing and reappearing through solid barriers. In classical physics, if you throw a ball at a wall, it will bounce back. But in the quantum world, things don't work that way. Quantum tunneling is a phenomenon where particles, such as electrons, can disappear from one side of a solid barrier and instantly reappear on the other side without ever physically traveling through it. This is not just a theoretical prediction. Quantum tunneling is a well-documented effect and is used in modern technologies such as scanning tunneling microscopes and quantum computing. If particles can seemingly bypass the constraints of physical space, could it be possible that information in Google's quantum chip is doing something similar? Is the chip's computational data somehow jumping across an unseen boundary, reaching its final state before the process has even begun? 3. The observer effect. The universe changes when you look at it. One of the most famous mysteries in quantum mechanics is the observer effect, which suggests that the act of measuring a quantum system changes its outcome. In the classic double-slit experiment, when a single particle is fired at a barrier with two slits, it should logically pass through one or the other. However, when no one is watching, the particle behaves like a wave, passing through both slits at once and creating an interference pattern. But when scientists place a detector at the slits to observe which one the particle actually goes through, the wave-like interference disappears, forcing the particle to behave as if it only passed through one slit. This suggests that mere observation alters reality at a fundamental level. Now consider what's happening in Google's quantum chip. The moment computations are being observed, the rules of quantum mechanics seem to break down. Are the anomalies appearing because the act of measurement itself is interfering with the quantum states? Could the chip be revealing a deeper truth, that at the smallest scales, reality is shaped by observation itself? Could Google's quantum chip be the next piece of this puzzle? Each of these quantum mysteries hints at the same unsettling conclusion. We still don't fully understand how reality works at the quantum level. If Google's quantum chip has detected a new anomaly, it may be connected to one of these unexplained effects. Or it could be something entirely different, something beyond what we've seen before. Have we just stumbled upon a quantum phenomenon that rewrites the very fabric of reality? Are we witnessing the birth of a quantum revolution? What Google's quantum chip has uncovered could mark the beginning of a new era in physics. If these anomalies are real, they may point to an undiscovered layer of reality, one that has remained hidden until now. This isn't just a minor computational glitch or an isolated quirk. This could be one of the most important moments in quantum history. Scientists around the world are now working to replicate the anomaly, to confirm whether this is a genuine breakthrough. But while some are eager to push forward, others fear that we may have already crossed a line that cannot be undone. If quantum computers are interacting with something beyond our current models, then every experiment from this point forward could be taking us deeper into the unknown. The implications are staggering. Could quantum computing be unlocking hidden dimensions? Is it possible that these machines are tapping into forces beyond our control? Have we unintentionally triggered a shift in the very structure of reality itself? One thing is certain. Whatever happens next, we are standing at the edge of something revolutionary. Have we just crossed a quantum threshold that changes everything? And if so, what happens next? If our reality is shifting in ways we don't yet understand, wouldn't you want to know? Subscribe and stay ahead of these mind-blowing discoveries. Quantum anomalies. A deeper look. Quantum anomalies are not entirely unheard of. Quantum mechanics is full of strange behaviors that seem to defy classical intuition. Most anomalies arise from well-documented effects like quantum fluctuations, decoherence, or computational noise in quantum systems. In many cases, seemingly bizarre results in quantum computing can be traced back to known limitations. Quantum noise occurs because qubits are extremely sensitive to external disturbances, making them difficult to control. Decoherence happens when a quantum state interacts with its environment, causing it to lose its quantum properties. Even the most advanced quantum chips still experience error rates in quantum gates, leading to occasional miscalculations. But this anomaly is different. Unlike ordinary quantum fluctuations, which typically resolve themselves as statistical noise, these effects appear to be repeatable, structured, and non-random. Scientists have observed results appearing before computations have even started. Quantum states resisting collapse, and unpredictable data shifts that follow a pattern rather than random errors. These observations suggest a deeper underlying principle at work, something that doesn't fit neatly into the established understanding of quantum mechanics. To understand why this matters, we need to look at how quantum computers function. Unlike classical computers that use binary bits, quantum computers rely on qubits, which can exist in multiple states at the same time due to a phenomenon called superposition. This allows quantum computers to process vast amounts of information simultaneously. Additionally, qubits can become entangled, meaning their states remain linked no matter how far apart they are. Changing one instantly affects the other, a phenomenon that has been experimentally verified. Normally, quantum computers leverage these properties to perform calculations at unprecedented speeds. However, in Google's experiment, the chip appears to have produced results before computations were even initiated. This isn't something superposition or entanglement alone can explain. It suggests a violation of causality or the involvement of an unknown force. Not all scientists are convinced that this discovery is as revolutionary as it seems. Some argue that what Google's quantum chip is experiencing may simply be a calibration error in the measurement system, leading to the illusion of preemptive calculations. Others believe there could be an overlooked source of interference that has yet to be accounted for in the experiment. There is also the possibility that this is a quirk of quantum error correction, something unusual but still explainable within the framework of existing quantum mechanics. Skeptics believe that more testing is needed before making bold claims about new quantum forces or hidden dimensions. But even they acknowledge that if this effect persists under controlled conditions, it could force us to rewrite the fundamental rules of quantum mechanics. The scientific community is watching closely because if this anomaly turns out to be real, it may be the first glimpse of a hidden structure of reality that we were never meant to see.